industry for a while is that the future of reality capture that we're all talking about, we're seeing a lot about, but it's actually here today and accessible to all of us. So without further ado, Jay, the floor is yours.
Thank you, Elmer, and good afternoon, everybody. So as Elmer said, I'm here to talk today about the future of reality capture. And topically, the way we look at it at Faro is that the future of reality capture is now. And so that's what I'm here to talk about today. And for me, being able to stand up here is more like telling a story. So bear with me. We're going to tell a little story about Faro, and we're going to tell a story about kind of how we believe we've reached at the point the future of reality capture is right now. And the biggest piece of the presentation today is to just spark ideas for everybody here, whether you've used scanning technology or any of the technology we have yet or not. It's more to just spark your ideas and get your blood going. And so Faro, just as a company, if you aren't familiar with us, is the world's most trusted source for 3D measurement, imaging, and realization technology. And what that means in a more practical sense, though, when you look at our company, is you have a team of risk takers, a team of rebels, and a team of dreamers. And so a session like this, what's more important is to really talk about the dreaming side, because that's where we spend a lot of our time, just sitting there and dreaming about what else should we be doing. And I believe a lot of the people here, you probably all resonate with that. A lot of you are all in that same boat, dreaming about what else you can do for your businesses and to make your companies better, your individual businesses better. How do you make your life better? And quite frankly, what else can I do to change the world? And for us at Faro, that's what we think about a lot. For us, changing the world is all about how do we document the entire world in 3D? That's what we're always thinking about. That's what this company is all about. And we'd like to do it, there's sort of 4 different ways we think about it. One is to do it with accuracy and clarity. And at the same time, it can't just be about the technology, so we want to do it with simplicity, and we want to do it as inexpensively as possible. And that's what the Faro dream and what the Faro workforce is all about. And so personalizing the ability to capture and document in 3D, because everything in the world has 3 dimensions, as everybody here knows. And it's really about the fact that the need for more detailed and more accurate information continues to grow every day. And we sit there and we ask ourselves questions all the time of, why do people still work in 2 dimensions when the whole world is in 3 dimensions? And why do people still use basic point-to-point measurements? Why do people still use traditional cameras? And why do they use tape measures? So we ask ourselves, why can't all of that be done with one device in full 3D? And that's how we as a company arrived at what we do today, not only in this industry, in this space, but also in the hard manufacturing world and all of the technology that Faro offers. And so when we think about that dream, what it first led us to as a company was this product here, the Faro ScanArm. And all 3 of these products are out in the booth today. If you want to look at them and play with them, we encourage it for anybody who's here. ScanArm is 12 feet of range. It was originally designed for the manufacturing world. High precision 3D measurement and imaging, so 50 microns of accuracy. So you're in fractions of a hair of accuracy of this device. In a portable device that's very easy to set up, very easy to use, and at a price point in the industrial world at $60,000, extraordinarily low, with full interface and seamless integration with virtually every 3D software package that's out there. And for us as a company, our roots go back to actually started in the medical world, but that has quickly morphed over time. So we saw the opportunity in industrial where you need high precision, and you need to work with dark parts and shiny parts, and you need to work with relatively complex shapes, and then you need to work with even more complex shapes that also include dark and shiny altogether with the complexity of that shape. But as the company was growing, and this has been developing over 30 years now, one of the things that we saw was that people were also starting to use the devices in other ways that we hadn't necessarily intended. So we saw people starting to use them in art, capturing statues and things of that nature. We saw people starting to reverse backwards sort of towards medical, and not quite medical in this application, but scanning really unusual features and having the question marks of, well, what do you do with that kind of data now that you can get that density of data on a person? And people starting to think about it for, are there other medical types of applications that we could be using, beyond the fact that it's really fun to look at Jay Leno's chin sticking out in full 3D, in full point cloud at 50 microns of accuracy. Who knew we needed that much accuracy on Jay Leno? And so it got the Faro team dreaming again. And we're looking at that saying, okay, well, those are all small objects. Those are all small parts and things that we are scanning. So why can't we sit there and go out into the middle of the forest and do the same thing in a very large space with extraordinarily complex features? Why can't we go out there and scan it as easily as we can with that ScanArm and create these fantastic 3D models just by going out there and taking a series of scans with a device and piece those together to create a capture of something as complex as a forest, of all the trees and the leaves and the gradient changes and the textures that are out there. And so that was one of the things that had the team thinking coming out of those first experiences. And likewise, we also said to ourselves then, why couldn't we go out there and do it in even a broader space and at the same time put together simulation and motion and movement in the models that are created by the technology that we can bring out there? Why couldn't we do that? And so we spent a lot of time asking those questions. Why can't we do that? Why can't we do that? And so what it led us to is this device, also on display out there. This is the X330 laser scanner. It can scan up to 330 feet in a single shot at roughly 2 millimeters of accuracy. 1 million 3D data points per second are captured. So if you're in here earlier today and people were talking about 800 a second, 1,000 a second, 2,000 a second, back when scanning was first being developed, you can now do 1 million points per second, extraordinarily lightweight, indoor, outdoor use, doesn't matter, and 100% eye safe. Also at a relatively low price for any of the professionals who are out there with that kind of guaranteed accuracy at $50,000. And so for us, it has opened up a whole range of applications and industries for people to use it in. So examples like heritage. We have a lot of people who I know have raised their hands saying they work in heritage. The ability to go out there and go to the Tower Bridge in London and take a series of scans, and I'll hit the punchline in a second here, to create a far out scan, so to be able to create the full external view of the Tower of London. And to go underneath and scan and get more detail up close and inside the layer of the bridge and get closer into the object itself. So in an as-built documentation situation, you now have in 3 scans, which took an hour, and half of that time was walking the scanner to the different positions, we now have a full 3D model of the entire Tower Bridge in London at 2 millimeters of accuracy. We have customers who use it in manufacturing now. So this is a plant in Volvo, and Volvo has an entire program using the scanner at all their manufacturing facilities today. And they scan the facility. They can then go ahead and import CAD models, so they can go ahead and simulate the movement of the new CAD model inside the manufacturing facility. They can also take that scan data and do it for the entire plant. So now the entire plant modeled, and anytime they want to do model changeovers, they can go ahead and immediately go to the data and do that simulation. So at Volvo, they've already done 2,500 scans across 6 plants. They're going to go to 8 plants. They've got 1,500 internal web share users today. So all the data goes up to the cloud, and their engineers around the world can use that data as they go ahead and do line changeovers, and they introduce new models into the process. And they're going to move to 6,000 users. All of that was done with 2 people using 2 scanners, and it's part of a program to help reduce their turnover time on new product changes by 15 months. And for a company like Volvo, a 15-month change in the amount of time it takes to take a new product from point A to point Z and get it in the market is a huge change. We've seen opportunity in construction. So this is a church in France. You can see the laser scanner there on the front left corner of the screen. And very rapidly create the 3D model of the exterior. You can look at it from the aerial view up above. And for this particular church, which had suffered storm damage, in a half a day, 2 people were able to create this entire 3D model and then identify where all of the cracks had occurred and put together their repair protocols for that particular church based on the data they had. This one I love because of the complexity of the structure. When you look at all of this intricate lattice work on this tower in Russia, we had one of our customers literally climb the entire lattice work. So here's the scanner. So only a scanner as small as the one you have with Faro can you bring that all the way up the ladder, set it up at the top, and in a matter of several scans be able to create a full 3D model like this, including all of the intricacy of that lattice work being captured again, and again at a couple of millimeters of accuracy, and be able to look at it from an aerial perspective and get the dimensional data that way, and to be able to export it to CAD to do fresh rendering and to be able to do a cleanup on it. And so in this case, 1 billion 3D data points were captured on that one particular tower with one person doing the scans. Oil and gas is another one we like to talk to, and I love these because of the complexity of what you have, and this is an offshore platform. Look at the piping and the vessels, and many of you may be familiar with that if you're in that space or you're in the construction world. There's the scan. That's a single flat scan of that same image there. then take the scan and be able to load the CAD data into it. So in this case, the customer is trying to identify where they need to feed the new pipes for additional vessels they're going to add into this offshore platform. And the key for the customer, the ROI here was incredible, because 107 scans over 2.5 days allowed them to collect all that data. And then by being able to fabricate all of the new piping and vessels offshore or onshore instead of having to do it on the platform, they saved $35 million on the project, because they didn't have to have all their welders sitting on that platform for weeks and weeks and weeks at a time trying to figure out what the fit was, and then go back and then try the fit again and then go back. So the ROI in these types of examples has been fantastic for Faro and for our customers. And the thing that then got the team dreaming again was, well, okay, that's all really cool, and we have this real high accuracy one for short range, and we have this pretty good accuracy one for long range. What if we sort of met in the middle and did something a little different, which also improved the price point and made the accessibility even better? And so we sat there and said, look, the Faro laser scanner is great, and it is pretty small. It's a small device, and you just set it up on a basic carbon fiber tripod, and that's all you need. But man, wouldn't it be great if you didn't have to have any of that, and we just used our hand? And that led us to the Faro Freestyle, which was just introduced about 6 weeks ago. Faro Freestyle is a handheld, singularly contained scanning device. It is nothing more than a T-shaped scanning device, a tablet attached to it. The tablet powers the scanner, and that's it. That's all you need for the device. With that particular device, you have 1 millimeter of accuracy still, up to 3 meters of range for the device itself, extraordinarily lightweight. You have real-time visualization on the tablet. So as you scan, you can see the point cloud building and generating of the object that you're scanning, or of the space that you're scanning. You can operate without targets, so it uses all the natural targets of the shapes and objects that you're scanning themselves. You can merge that data with the data from a long-range scanner, so you can do several long-range scans, and you can do several short-range scans and put them together, or you can use it independently by itself. Either one, it doesn't matter. And from a price standpoint, it really opened the door to still the professional world with the guaranteed accuracy, but sizably lower. So at $13,000, you get the entire unit self-contained with that kind of accuracy and with that accuracy guarantee that Faro provides. And so what we've already seen, even in the 6 weeks since it released, is people going out into the art world. You can walk up in a matter of several minutes, take the scans that you need. You can see on the tablet in the foreground there, you can see the statue visually, rendering in front of the user real time. And you can get very rapidly a model like that. That's several minutes of scanning. So if they'd scanned 3 or 4 more minutes, they probably could have filled in a few of the gaps that you see at the bottom there. We've seen customers now using it in forensics. We've done a lot of work with law enforcement in the past, and one of the things they kept asking for was, boy, if I had a handheld device to go along with the long-range scanner, that would be great. And so law enforcement is now using it for crash investigations and crime scene investigations. Here's a great example of one from a crash scene investigation at one of their training facilities. This scan data here was captured in 10 minutes, and then 10 minutes of rendering when they were done. So in 20 minutes, fully rendered at that level of detail with that level of accuracy. The color is overlaid real time with the scan data. All of that comes together in a single set of shots for that particular user. Here's another example of AEC. So we looked at a large external offshore platform with the long-range scanner. Here's a perfect example, and we have a setup of this out in our booth there today to sort of mimic the piping and wiring that you may see in a construction site. So you look at the detail of that and say, well, that's pretty complex, and if you need to capture all of that detail with the traditional methods, it's very, very difficult and time-consuming. So in this case, you have a user who can take the scan data and quickly and easily manipulate the data based on the data that was captured. And again, in several minutes, the user comes in, you plug into the tablet, you turn it on, and you go. That's the setup. That's how this device starts operating. And standing up close, up to 3 meters out, can capture all of the data of those pipes, of all of those pipes in there. Take it back to the office. You can render it. You can do whatever you want with it when you get back to the office. You've got that full point cloud. And again, in a matter of, in this case, about 20 minutes. So the capability of the device of taking all of the accuracy capability we had of our original ScanArms, then what we learned on the long range with the speed of capture and the density of the data that goes with it, and then combining that now into a small handheld device has led us to the Freestyle, and including now in forensics too. And well, I never thought I'd actually stand and present people a forensics example. This particular scan, and it is a dummy, I'm giving fair warning, it's not a real person, but you can see the density of the data off this one individual scan. So you have the user working with the tablet here and again watching real time what they're rendering. That is the scan coming out of the Freestyle. Full 3D, full color, accurate to a millimeter, give or take, and again captured in 10 minutes. So for forensics and for crime scenes, the thing that the law enforcement were really excited about was, I'm going to capture all this detail and data one time. The data is guaranteed, so they've been able to use it in court. It's been proven in the court system already, so it has that additional value to them of, they don't want to use anything they can't use in the court system. And you never run the risk of getting to the courtroom and somebody saying, hey, did you measure X to Y? And they go, oops, no, we didn't have that. You say, well, yeah, I don't have the data in front of me, but let me pull it up in the model and I can show you. And so again, just the applicability, and all of this is meant to, I don't know if we have anybody from law enforcement here, but it's the concept and the idea of how you can use the device and use the data in anything else that you're doing in the day-to-day world and the industries that you serve. So that leads to then the final piece of just, well then what else are we dreaming about? If we've done these things in the last few years, what else are we dreaming about for the company and the technology? One is certainly more mobility for the devices. So mobile devices on a vehicle, the ability to drive through towns at 40, 50, 60 miles per hour and collect not just visual data, but full 3D data at the same levels of accuracy, a couple of millimeters, and document streets, buildings, towns very, very rapidly. The next is making it more mobile for pre-programming and making it automated inside of, say, a manufacturing facility. So literally being able to pre-program all the scan positions, and every night you can run the robot out there and it will take all of the scan data. You get back to the office the next day, you've got all your scan data from the night before. If you're in a facility where you're looking for changes one day to the next, inventory, things like that. Can you take it to the air? Yes, you can take it to the air. We have a customer who's used it with, in several instances with an octocopter. There's the scanner upside down mounted to the octocopter there. So again, for us, it's the possibilities of what else can we do to make it more mobile. Second thing is continue to improve the ease of use. Now look, the Freestyle, the laser scanner, all of them are pretty easy. If I set it down on the floor here, any one of you would walk up and you'd know how to use it in about 2 minutes just playing with it. It's that easy. So what else can we do with ease of use? Well, a lot of it is based on personalization. So first is collecting the data is really simple. Taking the data and then bringing it back to the office and rendering it to get to where your final file is good, but it could be better. So one of the things that we are not surprisingly working on is going from that to basically scan to your final rendered data real time on everything, not just on the Freestyle. We do it on the Freestyle already. We need to continue working on that for the long-range laser scanner, but that's not a matter of if it gets there, it's just a matter of when it gets there. The total cost of ownership is very important as well. So we've already been able to take devices that you traditionally would need a purchase order for, and with the Freestyle, certainly you can purchase the Freestyle with a credit card, and we're happy to take one if anybody's ready to do it today. The real question for me, though, is when do we get to the point where the cost of ownership is low enough that it's the equivalent of, you could, it won't quite be pulled out of your wallet and pay, but can you get to the point where it's pretty close to just saying, look, that's cheap enough, I'll just pay cash for it? That's where we're headed with the technology. That's a piece of that continued enabling and mobilizing the world to be able to use all these different types of technology in your lives day in and day out. And the personalization piece is also really important to us as well. So over the last 6 months, we've done a couple of software acquisitions now, one called the CAD Zone and one called Aris 360. They are entirely focused on law enforcement and forensics. That's a market that we really have started targeting because of the utilization they already have with the technology today. And what we've done is those two software packages were specific to law enforcement. They're already incorporating point cloud data and camera data from traditional devices, point-to-point measurements and cameras from traditional devices. They already have all of the workflow and the processes that law enforcement are used to using. And so what it does then is it allows us to transition that workforce from 2D to 3D, still using all of the protocols and all of the current workflows that they have. And when you look across all the different types of markets that we're already selling into, and this is just a fraction of the ones who are using our scanning technology today, there are lots of other ways for us to do that in the software world to personalize the hardware to all of your individual needs, your individual business needs, while still maintaining the same hardware and the stability of the hardware that all of you would expect as well. And so yes, we're going to be able to personalize, certainly by industry, definitely by application. We've had some say, hey, can you even personalize it by customer? Maybe, we'll see. That's something we're still working on. But I will say is that we've taken a pretty good step forward on that as well with the Faro Web Center. We already have Dozens and dozens of apps out there that are written by some Faro people, some of our customers. We have, you have the ability to write your own apps. You can upload them up onto the App Center. We'll help you do that. We'll help you make a little money off it at the same time if you want. That's the personalization of, we have some apps that are specific to one single application. So not just an industry, not just a vertical, it's one specific task and that's all they're doing it for. And it's an easy way to continue enhancing that use for the customers on a one-off basis. My sales hat goes on every once in a while, so this is that moment. Don't wait for any of it. The scanning technology is here today. If you're interested, we're happy to show it to you. We are always happy to sell you one. So the sales team always makes me say, please tell them not to wait for anything that's coming next. Go ahead and think about buying now today. So now I'll take my sales hat back off. So what are the conclusions from what I just talked about and and again, the whole goal here today was to just spark the interest, the ideas, and some thoughts on what else you could be doing with scanning technology in your worlds day in and day out today. Doesn't matter if you want high accuracy, if you want long range, if you want low price, or you want whatever combination of that there is, that's what Faro is all about. And for us, and I think again for everybody here, the real message is that something we all know is the 3D revolution is well underway. Working in 3D is going to change industries permanently, and we all know that for certain. And the one thing that we like to think about at Faro, again, the dreaming and the rebel and the risk taker side of our company is that we believe we're leading the charge, certainly leading the charge on the capture side, and we'll continue to do that going forward. We look forward to hearing from you, your thoughts. Go play with the technology, see what you think, and love to have you take a look at it. So with that, that's what I had to say. Thank you.
Thanks, Ed.